So we'll be starting with arithmetic progression, okay? In CBSE, it is only covering arithmetic progression, okay? And if you want, I can cover the GP also, geometric progression. And CBSE, you'll be having a geometrical progression in your class 11th or 12th, okay? So we'll start with arithmetic progression, okay? So what is arithmetic progression? Before that, we'll just look some common definitions, okay, or some terms we should know. That is, what is sequence, what is series, what is progression, okay, to understand that what we are going to now. Okay. Now, sequence. What do we mean by Safia? Are you back? Safia, are you back? Okay, just she asked for 2 minutes. Safia, are you back now? Okay. So, what is a series? Okay, because you'll be listening about series. So, a list of numbers arranged in a definite order. Okay, a fixed definite order is there, okay, in which it is arranged, okay, according to some definite rule, okay. For example, they are arranged in a ascending order, they are arranged in a descending order, okay, in some sequence, okay. You can see the example 1, 10, 12, 16, 10, okay. So this is a series because they are arranged in the ascending order, okay. Now second one, similarly, it is a series. Why? Because each number is one more than the number preceding it, okay, except the first number, because first number you will be having, it cannot precede the any other number, okay. You are going to start from somewhere. Similarly, you can have you can call the list of all the even numbers as a sequence, list of all the odd numbers arranged in a proper format as an sequence, okay. Similarly, difference of 5, divisibility of 7, 8, okay. So there can be different numbers that are arranged in a fixed pattern, okay. You could call them a sequence, okay. Now here, each and every single number in this sequence is called a term, okay. Each and every single is called a term, okay. Now, consider sequence. Now, this is a sequence. So, what is A1? Okay, if you are writing, so the first element can be represented general sequence if I'm telling, okay, in AN. So, this is your first term, and similarly, this is your second term, and so on. And AN is the nth term, okay, or you can say a general term. We can represent any single term of an you can say sequence or in further arithmetic progression as an, okay, because this will be a general term, okay. Now I have already mentioned here an is a general term of the sequence, okay. And a sequence can be finite or infinite. Finite, everybody know the meaning of finite because they have some limit, okay, and infinite that doesn't have any limit, okay. Like series is going on, okay, so sequences keep on going, okay. There is not, last term is not mentioned there, okay. So it will keep on, like if I'm talking about even number, so there can be an infinite even number. But if I'm saying 2-digit even number only, okay, so that is having some limit. So this sequence is finite, okay, whereas just the sequence of even numbers cannot, is not finite, is an infinite sequence, okay. Now what is series? Okay, sequence and series. Series is sequence we have seen. Now series is what? When the number or terms in a sequence are connected to each other by positive or negative sign, okay, then the sequence becomes series, okay. When there are negative and positive signs are there, then that sequence, that particular sequence becomes a series only, okay. So a series is finite or infinite again, okay, because sequence can be finite or infinite. So like you see here, 2 plus 4 plus 6 plus 8 plus 102, there is an infinite and it is a series also, okay. Infinite set, sorry, finite series, okay. Now the below one is an infinite, you can see dot dot here, so that means there's no stop here, okay. And -3, -9, -2, so here the first one you can see plus sign is used and the second one minus sign is used, okay. So it is called a series, okay. This, now what is progression? Those sequence whose terms always follow certain pattern are called progression, okay. And we will be studying about arithmetic progression where they are going to follow some pattern, okay. And we'll see what is arithmetic progression. So since progression is a series only, but which is following a certain pattern, so every progression will be a series, but all the sequence, every progression can be a sequence, but all the sequence cannot be a progression. Okay, because that particular sequence which is following a pattern is only called a progression. Okay, now for example, I have already mentioned here two example for your understanding, that is the sequence 3579 is a progression. Okay, as each term can be found by adding 2. Okay, the difference between these two terms is 2. Similarly, in these two also is 2. Okay, and in these two is also 2. Okay, similarly in the below one you can see there is not any pattern. Okay, and terms are not following. Wait, just give me one. Okay, so above one is a progression because it is following some pattern. There's a common difference between the first term in all the terms. Okay, like the progressive term. Okay, so 3 and 5, same difference, that is 2. 5 and 7, same difference, 2. 7 and 9, same difference, 2. Okay, and the second one is not a progression. Okay, it is a sequence, but it is not a progression because there is no any pattern between the numbers. 3 after 3, 10 is there. Okay, and if you count the difference, so this difference is not same in all the numbers, and there is no any other pattern also you can find. Okay, that is that they are following even number or number. Okay, so no pattern is there. And this line I have already mentioned that all progressions are sequence, but all sequence are not with progression. Okay, now arithmetic progression. Arithmetic progression is also a sequence which is following some pattern because it's a progression. Okay, now what type of a pattern they follow, we'll see. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term. Okay, except the first term because the series is going to start from somewhere. Okay, so fixed number 2, 4, 6, 8. Okay, this is an arithmetic progression because they are the difference between, and yeah, I have mentioned here what preceding term. Okay, the difference between the two terms, the preceding one. Okay, just after this, the continuous term. After 2, the preceding term is 4. So you will find the difference of 4 minus 2, which is equal to 2. Okay, now preceding term of 4, 6 minus 4, which is equal to 2 again. Again the preceding term. Okay, which is equal to 2. Again the preceding term, which is equal to 2. You're not going to take the difference between 2 and 6 or 2 or 8 or 2 or 10. Okay, just the preceding term. Okay, just after the means the present term, just after that the next term. Okay, the preceding one. Okay, which is succeeding it. So the difference between the preceding term and the previous one, it is taken as a common difference. Okay, you need to find out when it is asking you that it is an arithmetic progression or not. So you need to find out difference between all the terms, all the preceding terms, like 2 and 4, then for 4 and 6, then 6 and 8, and 8 and 10. And if they all are having common difference, then it is called arithmetic progression. And this number is called common difference, and it is represented by a D. Okay, and since this is first term of the series, so it is called, this is the first term. Okay, understood? Now you can see a general arithmetic progression, how you are going to write a general arithmetic progression: A1, A2, A3, A4, so on, and a general term by AN. Okay, now how can this A1 is the starting term. Okay, this is the first term, and you cannot get the first term, you need to have first term. Okay, but how you'll get the second term? It is A1 plus D. Okay, in the first term, if you are going to add the common difference between the terms, okay, then you will get the second term. Similarly, how you will get the A3? You will get the A3 by adding common difference to the A2. Okay, A3. Okay, you'll get A4, A3 plus D. Okay, and so on. Okay, and how you'll get AN? You'll get AN minus 1 plus D. Okay, so this is a general, you can say, a statement how you will get a next term of the arithmetic progression. Okay, like A1. If I'll tell you, I can give you the first term of an arithmetic progression AP, and I'll give you the common difference, so you can find the complete arithmetic progression series. Okay, how? Like, you know the common difference. So in the preceding term, you are going to add, and you will get the next term. In A1, if I'll tell you A1 is 2 and the common difference is 3, so 2 plus 3, you'll get 5. Okay, then again you will add 3 and 5, you'll get 8, and again in 8 you are going to add 3 and you'll get 11. Okay, so on. Yeah, in general, the you can say, and in general, this is represented as an arithmetic progression. Okay, in general means a general arithmetic progression can be represented in this way. Okay, where A is the first term and D is the common difference. Okay, and how it is represented? I'll write general AP. I'm writing AP is for arithmetic progression. Okay, A plus D, A plus 2D, A plus 3D, and so on. Okay, so this is a general AP. If it is not mentioned, the general AP, you can take it like this. Okay. AP can also be an finite or infinite. If terms are AP is finite, so it is called finite AP. If it is infinite, so it is called infinite AP. Okay. Now you can see a question here. Examine. Till here, any doubt? Safia and Rudronian, that what is an arithmetic progression, or what is a general term of an arithmetic progression, or which type of a series we can call it as a arithmetic progression. Safia and Rudronian, any doubt till here?
No, ma'am.
Okay, so let's start with the question. Okay, examine that the sequence 13, 10, 7, 4 is an AP. So how can we check that this sequence is an AP or not? Okay, by checking the common difference. If they are having the same common difference between each preceding term, so it is in AP. So if you will do 13 minus 10, okay, so 13 minus 10, if you do, you will get the answer minus 3. Okay, not 13 minus 10, 10 minus 13, because the preceding term you're going to minus. Okay, so A2 minus A1 if you are going to do, so 10 minus 13 will get minus 3. Again A3 minus A2 you'll do, so again you are getting minus 3. A4 minus you'll do minus 3. Okay, so you can see the common difference is same everywhere. Okay, since the difference is same, difference is any of the preceding term is constant. Okay, it is same here. Therefore, this series is an AP. Okay, but if in any of the if you'll get any of the number that is different from the common difference, okay, or you get different numbers, okay, when you're checking the common difference, okay, when you're subtracting the preceding term with the previous one, okay, you don't get a constant term. Okay, every time you are getting a different one, so that series is not in AP. That sequence is not in AP. Now, similarly, another question, examine that the list of numbers obtained from following situation will be in the form of an AP. Okay, amount left with Sandeep in rupees out of the total amount of 12,000 which he had in the beginning. So Sandeep had 12,000 rupees in the beginning, in the starting. Okay, when he spent rupees 500 in the beginning of every month. Okay, every month, in the beginning of every month, he's going to spend 500 rupees. Okay, so we need to check if this situation is forming an AP or not. Okay, so the total amount that Sandeep has, it's 12,000 rupees. So in the beginning of every month, he is spending 5,000 rupees. Okay, so in the first month, he had how much money? 12,000 rupees. So in the beginning of second month, he will spend the money 500 rupees. So what will be the next amount he will be having? That will be from the previous one. We are going to minus the initial amount that he was having. We will be subtracting 500 that is spent. So we'll get 11,500. Similarly, in the beginning of the third month, he'll had in this new term we are going to subtract 500. Okay, and in again in the next upcoming month he's again going to we are going to subtract. Okay, in the new whatever answer we are getting here, from that we are going to subtract again 500. Okay, so you can see it is forming a AP because every time the difference between is 500. Okay, that is minus 500, you can say. Okay, because the first term, the initial term in the series was 12,000. Okay, now the next term in the series is 11,500. Now the next term in the series is 11,000. Okay, now the next term in the series is 10,500. Now the next term what will be? It will be 10,000. You can see they are forming a AP. The difference is always 500. Okay, we have got the new term by adding 500. Sorry, subtracting 500. Okay, we are getting the new term by subtracting 500 to the previous one. Okay, so this is forming an AP because the preceding term, you can say the difference between the term and its preceding term is constant. Okay. Now, method to find the common difference of an AP. How you are going to find the common difference of an AP? You are going to subtract the given term, or you can say you are going to subtract the term with its preceding term. Okay, every time you will take the term and its preceding term and you are going to subtract it. Okay, from the preceding term, you are going to subtract the term. Okay, that is here in the series, it is given A1, A2, A3, A4. So the difference will be, I'm writing it A1, A3, A4, and so on. Okay, AN. Now D, we represent the common difference with D. Now this D is equal to A2 minus A1. Okay, the term is A1 and A2 is the preceding term. Okay, which should be equal to A3. The term here is A2 and the preceding term is A3. It will be equal to and so on. Okay, whatever terms are here. So this is going to represent your D. Okay, if you already know that that a series that a sequence is in arithmetic progression, you can find out the any of the you can take any term and its succeeding term, its preceding term, and you can subtract and get the D. Okay, but if you are checking that that particular sequence is in arithmetic progression or not, then you need to check the difference between all the terms. Okay, the terms that you can that they are already on that given. Okay, it's not necessary that all the terms are mentioned only. Okay, but you need to find out for some of the terms, 5 6 terms. Okay, so that you can be sure that this particular sequence is in arithmetic progression. Yeah, now this D can be positive, negative, or zero also. But what do you say? If it is zero, what will happen? 1 minus 0. You'll every time you'll get the same number. Okay, every time you're going to get the same number if common difference is 0. Okay, now let's check the question. Now first one, see, find the common difference of the following AP. So how we are going to find out the common difference? Here you can see A1 is equal to 3, A2 is equal to minus 2, A3 is equal to minus 7, and A4 is equal to minus 12. Okay, so D will be equal to A2 minus A1 equal to A3 minus A2 is equal to minus A3. Okay, so we need to find out. So if you are going to subtract minus 2 from minus 3, you get minus 5. Okay, if you are going to subtract minus 7 from plus 2, you'll get again minus 5. Okay, minus 2 plus 7, 4 minus, you're getting plus 7, plus 5. Oh, sorry, I have not written correct. Yeah, so minus 12 plus 7, again you'll get minus 5. Okay, if I would have got 5 only, not minus 5, then it would not be in AP. Okay, that's why I was thinking that common difference, it is checking that it's already written that it is in AP. We have to just check common difference. Okay, so this is in AP and the difference D is equal to minus 5. Okay, now similarly you can do the second one also. See, second one you don't need to check because you can see all the terms are 11 11 11. So every time you're going to subtract the term from its succeeding term, from the preceding term, so you'll get always a 0. So here D is equal to 0. Okay, now You will see the third one. In third one, what we are having 5, 1 by 2, 9, 1 by 2, 30. So first of all, we are going to change it in a proper fraction to subtract it. So 11 by 2. Okay. So you are getting this term. Okay. Now D will be equal to 19 by 2 minus 11 by 2. Okay. So what you will get? 4. Similarly, 27 by 2 minus 19 by 2. Oh, wait. Yeah, 35 minus 27. Okay. So we are getting 4 everywhere. Okay. Any doubt?
No, ma'am.
Now, method to write an AP when first term and common difference are given. Okay, so how can you write a complete arithmetic progression if only first term is mentioned in your question, only first term is given, and the common difference is given to you. Okay, so let's see a question how we are going to do. Now, what is the general AP that you are going to take here? That will be A plus D, A plus 2D, A plus 3D to get the required AP. Okay. So we are having a question here, question number 4. Write an AP having 4 as the first term. It's written 4. Okay, you are going to mention the 4 with an A. Whenever you are solving a question in arithmetic progression, A represent the first term. Okay, and if you are mentioning any other particular term like A4, A15, so you have to mention the number below. Okay, little below A4, A20, A15, A30, AN. Okay, actually AN. Okay, this is your common term. I only told you general term, in fact, not common term, a general term. Okay, this N. Whenever you are mentioning any specific term, you have to mention the value at N. Okay, so A is written, A is equal to 4 as the first term and minus 3 as a common difference. So D is equal to minus 3. Okay, you don't need to mention the complete common difference. You can just write the D also, because everybody knows D here represent the common difference. Okay, if you're mentioning, that's good. Okay, now we need to find out the AP. So AP, we are taking A plus D, A plus 2D, A plus 3D. This is a general AP. Okay, if it is not given. So if you are writing here, so A will be 4, already mentioned. Okay, the next term in the AP will be 4 plus minus 3. The next term will be 4 plus 2 minus 3. The next term will be 4 plus 3 minus 3. Okay. So what you will get? 4, comma, 1, comma, minus 2, comma, 6, no, 9, 5, minus 5, and so on. Okay. So this is your required AP. Okay, and in fact you already know that you can find with the arithmetic, in fact it is in one number. You can just generally write this and you can directly do it like it is 4. A is 4. Okay, in 4 if you are going to subtract my since it is not, it is common difference is minus 3, so I'm said subtract. Okay, so if you're going to subtract minus 3, so it will get 1, and in 1 if you are going to subtract minus 3, so what you will get? Minus 2. In minus 2 you are going to subtract minus 3, so you'll get minus 5, and so on. Okay, understood? So series will be A, means a general, means not general term. A general term in an AP AN is equal to AN minus 1 plus D. Okay, I followed this and find out all the term. Okay, but if you need to find out the GP, so you can just take this as a general AP and find. Example is now, which of the following are APs? If they form an AP, then find the common difference D and write 3 more terms. Okay. Now it is asking you, you need to check among these 3 questions that which of them are forming an AP. So for checking that which of them follow AP or which of them are in AP, so we need to find the common difference. If it is same for all the terms, then it is in AP. And if it is in AP, so if they form an AP, then find the common difference D and write 3 more. So common difference already we are going to find out. So you'll get the common difference and we have to find out more 3 preceding terms. Okay. So let's start with the first one. 2, 4, 8, 16. So from seeing only you can see that it is not in AP, because the difference between, but still you need to show in the examination. 4 minus 2 will be 2. Okay, the common difference is 2. Now 8 minus 4, your common difference is 4. 8 minus 16, your common difference is 8. Okay. So this first one is not in AP. Okay. Understood? Why? Because common difference is not same. It is not common. The difference between the two terms is not common. Okay. The D is not same. It is not constant. Constant. It is varying. So it is not a common difference. It is not in AP. Now for the second one, 2 comma 5 by 2, 3 comma 7 by 2. Again, we are going to find the common difference. So 5 by 2, A2 minus A1, 5 by 2 minus 2. Okay, 5 by 2 minus 2. Okay, it will give you 1 by 2 half. Okay, again 3 minus 5 by 2, it is giving you 1 by 2. Again 7 by 2 minus 1 by, 7 by 2 minus 3, it will give you half. Okay, so you can see the D is same. D is equal to half. Okay, so therefore in AP, the difference is same in all the whenever we are subtracting the term with the preceding term. Okay, so it is in comma, it is in AP. Now we need to find out, since it is in AP, we need to find out the next three term. So how we are going to find out the next three term? Like we have already are having till 4 terms. Okay, so the fifth term we need to find out. A5 will be equal to A4 plus D. Okay, what is the D? D is the common difference is half, and A4 term is what? A4 is 7 by 2. So 7 by 2 plus half. Okay, which will give you 8 by 2. Okay, so 8 by 2 will give you 4. Again, A6 will be 4 plus 1 by 2. So 9 by 2. Okay, A7 will be 9 by 2 plus 1 by 2. 10 by 2, that will be 5. Okay, understood? Still moving on. Okay, now solve the third one. Solve the third one. Check that it is in AP or not. It is in AP or not. Prodhonia and Sapya, the third one. You're still doing. So common difference is what in the third one? Sapya, have you checked the third one? Let me check here. Minus 1 point minus 3 minus 5 point. So minus 3.2 minus minus plus 1.2 will give you what? Minus 2. Okay. Again minus 5.2 minus minus plus 3.2 again will give you minus 2. Minus 7 by 7.2 plus 5.2 will again give you minus 2. Since D is equal to minus 2, so it is in AP. Okay. And next 4 term means A5 will be equal to A4 plus minus 2. What is A4? Minus 7.2 minus 2. So it will be minus 9.2. Okay. Similarly, A6 will be, A7 will be. Any doubt? Safia Rudroni, any doubt? No. We'll see just the theory, and then tomorrow means on Thursday. Thursday we'll see. And in the next week, we'll be having a test. In the next class, I will try to assign all your circle assignment, whether you means you can take your time to do, but just go through the question so that you don't find if any doubt is there in any of the question, you can just solve it. Okay. So that in the next week, we can have our test. Okay. Now, properties of AP. What are the properties of AP? If a fixed number is added or subtracted from each term of an AP, then the resulting sequence is also an AP. Okay, fixed number is added or subtracted from each term. Okay, each and every term, if you add or subtract a same number of this in the sequence of an AP or of an AP, okay, then the resulting sequence that you get after that is also in AP. Similarly, if each term of an AP, okay, each term of an AP, I'm emphasizing on each term, okay, not even a single term you have to leave. Every term, each term of an AP is multiplied or divided by a fixed non-zero number, then the resulting sequence is also an AP. Why it is written non-zero number? Because everybody know if we are going to multiply with 0, the number will become 0. So whole series will have 0. And if you're going to divide with 0, it will become infinite. Okay. So non-zero number, it should be a non-zero number. Then the resulting sequence is also an 8. Okay. So whether you multiply or divide or add or subtract, but to each and every element of each and every term of an AP, then the resulting sequence that you get after this, that will also be in AP. Okay. general term or nth term of an AP. Okay, if you need to find out any term, okay, for example, in an AP, it's not necessary that there are only 10 terms. It can be 20 terms, 100 terms, 110 terms. Okay, and if I'm asking you, it's not possible to mention all the terms. Okay, I can just give you starting some 5 numbers. Okay, so you from 5 numbers, and I tell you that it is an AP, and then find out the 100th term. So how you can do? You already have the A. Okay, so there is a formula to find out any term. Okay, nth term of an AP. The nth term of an AP is AN is equal to what? A plus n minus 1 B. Okay, this is the same thing. You have seen that like A2, we have find out A2 by A1 plus B. Okay, now A3 we find out like A1 plus 2D. Okay, or what we were doing? We were doing, no, I'll explain you this. Okay, so A3 we have written as A2 plus D. Yes, now A2 can be written as from here. A2 can be written as A1 plus D plus D. So A1 plus 2D. Okay, and A1 is what? It is the first term. Here A1 is the first term. Again, if you go for A4, so A4 is A3 plus D, and A3 can be written as A1 plus 2D plus D. So it will be A1 plus 3D. Okay, so you check here. So what you are getting? If you are finding for 4, A4, so we are writing A1. That is the first term. Okay, plus you are writing 3, which is, if you are finding up of AN, so it will be n minus 1 D. Okay, so here n minus 1 is the, what you can say, and D is the common difference. Okay, and here if I'm writing as n is the nth term. Okay, any nth term. Okay, so if you know the initial term, the first term, and the common difference, then you can find any term of the AP, whether it will be 100th term or 200 term or a 150 term. Okay, you just need to have the first term and the common difference. Okay, in the if you are finding A100, for example, if you are finding A100, so it will be what? A, there you don't write A1. Okay, A, simply A will represent the first term, A plus n minus 1, so 100 minus 1. Okay, and D, so it will be actually A plus 99D. Okay, so you will get the 100 term. Similarly, any term you can find, whether it is 20, 21, 23, 25, any term. Okay, now what is the last term? Again, the last term is also n is equal to a n minus 1d, but here n, a is the first term and d is the common difference again, and here L, if you are representing the last term or you are finding the last term, the nth term is known as the last term of an AP, and it is denoted by N. Sorry, L. Okay, this is AN is for general term. Okay, the same formula you can see there is no difference is there, but AN represent the nth term, any term. Okay, and L represent the last term. Okay, just one question, and after that we'll end the class. Okay. Find the 20th term of the sequence. Now you already have the sequence. So from here, you'll see A is 7 and D is what? D is minus 4. Okay. If you're subtracting 3 from 7, you'll get minus 4, minus 1 plus, minus 1 minus 3. You'll again get minus 4. So D is 4. Okay. Now 20th term. So A20 is equal to 7 plus 20 minus 1 minus 4. Okay, so A20 will be equal to 7 plus 19 minus 4. Okay, so A20 is equal to minus 16. Understood? Are you going to find out any general term of an AP? Any doubt, Satya and Rudronial?
No.
So we can end the class here and we'll see you on Thursday. Okay, bye-bye.